All right, y'all, we're back, and now we're going to focus on how we can solve a couple of practice problems with this process of elimination. Remember, it doesn't matter whether you solve with substitution, graphing, or elimination, you still get the same thing through either of the three or any of the three methods. But sometimes the situation is set up so that it's easier to solve with substitution than elimination, or vice versa, and rarely you'll find that graphing is the easiest way to find your solution. So yeah, we'll take a look at these four problems. Each of them we're going to solve with elimination. You're going to see the differences between each of these scenarios because sometimes there's a little added work you have to take care of before you can actually eliminate one of your variables. So we're going to get into this first system here. Let me go ahead and get that in view. All right, good. So our first system here says x plus y equals 7 and x minus y equals negative 3. What you're going to notice about each of those systems is looking at our y's here, and maybe you call it the coefficients for y because you know there's a 1 in front of both of those. Identity property tells us that. But you notice that they're opposites, right? Same coefficient and same or opposite signs. So these are set up very nicely to cancel each other out if we add these two equations together. And that's the bit of advice I'm going to give you. When you're solving with elimination, make your life easy and always set up the system to solve by the elimination when you add the two equations together. You're going to see what I mean by that a little bit later, but just keep that in mind, all right? If you eliminate as many things as you have to think about as possible, makes your life solving these problems a ton easier, all right? So we're going to go ahead and write out x plus y equals 7 and x minus y equals negative 3. And again, all we're going to do is say we're going to combine those two equations with addition, all right? Remember, these x's and these y's can be considered like terms. I'm going to go ahead and actually make that a y. I don't know why I wrote a 7. We're going to make these x's and these y's are like terms because we know if we're looking for where these two lines cross, these x's are exactly the same number and these y's are exactly the same number. All right? So let's go ahead and do that addition. X plus x, that's going to get us 2x. Y plus negative y, adding together opposites, is going to cancel them out. So those are gone. And 7 plus negative 3 is going to be equal to 4, because 7 plus negative 3 is the same exact thing as saying 7 minus 3. So we had 2x equals 4. All we have to do now is get x by itself, and that's going to happen with division. You're left with x equals 2. All right? Now all we have to do is take that solution for x, and we're just going to plug it back into either one of the equations. I'll pick the top one because everything's positive, not too much to worry about. So x plus y equals 7. But now instead of saying x, we know the value of x is 2. Now when I plug that number value back in, or if it's an expression, I always use a parentheses instead of parentheses. And what that does is help me make sure that I'm maintaining the relationships. I'm not unnecessarily and incorrectly getting rid of any negatives. I'm just making sure that the relationship that was there when we had x as a variable is still there when I've substituted that value of x we found, which is 2. And now we can go ahead and solve this. 2 plus y equals negative 3. Or that's supposed to be minus. No, that's... Oh, I'm making a mistake here. That should be 7. Excuse that. So 2 plus y equals 7. We can go ahead and we know we can drop those parentheses with associative property. And so now we're left with just needing to subtract on both sides. And we end up with y equals 5. All right? So we have an x, we have a y. We know where these two lines cross. That is at the point 2, 5. Now, hopefully you remember this system from the first video for this station. It's the exact same system, but you see just how much easier it is to solve with elimination than it is with substitution, and that's primarily because of how the system is set up, right? Notice that both of these equations are in standard form, and usually when that's the case, elimination is going to be the way to go in terms of solving. All right, let's move over to the next one here. And our next system says x minus 2y equals 10 and 3x plus y equals negative 12. So what you notice about this one is that right now, neither our x's nor our y's are set up to eliminate, right? We got a coefficient of 1 and a coefficient of 3. We got a coefficient of negative 2 and a coefficient of 1, right? You go ahead and just fill in those blanks with 1s. Let me make that blue there a little thicker so that you can see it. So right now, we're not really set up to eliminate like in the last problem because none of our variables at the present are going to cancel out, right? But I think we have an easier path to take here, and it's going to be focusing on what's going on here with the y's, right? What we notice is the coefficient in front of y is a 1. Put that back. And what's nice about 1 is that you can multiply into whatever number you want to, right? 1 multiplied by anything is that number. So we're going to focus on changing the second equation with multiplication so that even if these two equations won't cancel out a variable now if we add them, they will after we make a slight edit. All right? So I'm going to start by saying x minus 2y equals 10. We're not going to touch that equation, but we are going to touch the bottom one. 3x plus y equals negative 12. And how are we going to adjust that? We're going to multiply everything in that bottom equation by 2. All right? What that's going to do is it's going to cancel out with that negative 2 we see up there in the first equation. And so now our system is going to look like this. Again, x minus 2y equals 10. We're not changing at all. We're not touching that equation. But the second one we are. And we're going to do that by multiplying everything by 2. So 2 times 3x is 6x. 2 times y is going to give us positive 2y. And 2 times negative 12 is going to get us negative 24. Okay? So we've gone ahead and make it a little bigger. Get rid of this arrow because that was giving me space issues. Rewrite that. 6x plus 2y equals negative 24. So what we've done is we've edited that second equation. We've maintained its value, right? We multiplied everything by 2, so we haven't changed the value of anything. But what we have done is made it so now that if we add these two equations together, those y terms are going to cancel out, right? So let's go ahead and do the addition. X plus 6x is going to give us 7x. Negative 2y plus positive 2y, those two are going to cancel out. And 10 plus negative 24 is going to get us negative 14. Okay? Now, again, all we got to do is get x by itself. We're going to divide both sides by 7. And we end up with x equals negative 2. Okay? So that is our solution for x. And again, when we're solving with elimination, we're describing a point on a graph, and that's never going to happen with just one value. We need a y value as well. So we're going to plug that value for x into either equation to figure out the y value. I'm going to pick that second equation this time, so 3x plus y equals negative 12. But we're going to plug in that value for x we found, which we know is negative 2. So the equation is now going to read 3 times negative 2 plus y equals negative 12. And I would just finish off by solving for y. We know 3 times negative 2 is negative 6 plus y equals negative 12. And we're just going to add 6 to both sides to get us y equals negative 6. So again, we have an x value, we have a y value. We know where these lines cross on the coordinate grid. It is at the point negative 2, comma, negative 6. All right? A couple more like this, and then we'll handle a couple of application problems, a couple of conceptual things, and we'll get to go. So over here in our next system, you're going to notice that unlike the first one and unlike the second one, neither of our coefficients are set up so that our variables will cancel out, right? We got 6 versus 4. And we got 2 versus 3 for the y's. So it's not like the first equation where things just canceled out, or the first system where things just canceled out automatically. And it's not like the second one where we only had to change one of the equations because we had a coefficient of 1 for one of our variables. In this situation, we're going to have to change both of our equations. Now, what I'm going to tell you, the easiest way to think about that is with this idea of lowest common multiple. So I look for the lowest common multiple of 6 and 4, that is 12. And I look for the lowest common multiple of 2 and 3, that is 6. And usually I'm going to pick the smaller of those two to transform, right? So in this case, because I know the LCM for my y coefficients is 6, I'm going to decide, let's go ahead and set this up so that the y's cancel out. You see what that looks like. So we're going to take the top equation in our system, and we're going to multiply it by whatever we need to make this 2y become a 6y. That is going to be 3. All right? We're going to take this second equation. We're going to multiply it all by whatever it would take to make this 3y a negative 6y. And that's going to be negative 2. And multiplying by negative 2 specifically is going to make it so that these systems or these equations will cancel out when I add them together. Remember, I told you, you want to eliminate as much to think about as possible. Usually what that means for us here is, let's multiply one equation by a positive number and the other by a negative number. And we're going to see how that shakes out for us. All right. So let's go ahead and do all the multiplication with the top. Let me go ahead and change the color on these so that things don't get too confusing here. I'll make pink the color for the first one, and I'm multiplying everything by 3 up top. So 3 times 6x is going to get me 18x. 3 times 2y is going to get me 6y. And 3 times negative 12 is going to get me negative 36. Down below, negative 2 times 4x is going to get me negative 8x. Negative 2 times 3y is going to get me negative 6y. And negative 2 times 7 is going to get me negative 14. Okay? So we've adjusted both of our equations now. We're not changing the value of anything. We're just changing how they look so that now our y terms will cancel out when we add everything together. And 18x plus negative 8x, same thing as saying 18x minus 8x, is just going to be negative, or positive 10x. Right. If we go over here to the other side of the equal sign, negative 36 plus negative 14 is going to get us negative 50. And all we have to do is get x by itself with a little division. We end up with x equals negative 5. All right, now that we've taken care of that, we're going to go ahead, we're going to plug this solution back into whichever equation we want to get the other one. I'll choose the top one. Doesn't really matter here. It seems like they're both equally difficult. So 6x plus 2y equals negative 12. And now, like we said, we're just going to replace that x with the value we found, which is going to be that negative 5. 6 times negative 5 plus 2y equals negative 12. 6 times negative 5 is negative 30 plus 2y equals negative 12. We're going to add that 30 to both sides to get rid of it as a term. That's going to give us 2y equals 18. And we're going to finish off by just dividing both sides by 2. to end up with y equals 9. So that's our solution there. We now know where these two lines cross with an x value and a y value. They cross at the point -5 on x, 9 on y. And over here at our last system, we have a very similar situation. We have to edit both of these equations. If we look at the coefficients for x, I'll use blue for that, 4 and 5, their lowest common multiple is 20. And if we look over here at the y's, -6 and -4, their lowest common multiple is going to be 24 or -24. No, that's still 12. So let's go ahead then and let's choose that one. Let's say we want to make the y's cancel out. Again, usually I want to work with smaller numbers. So yeah, let's do that. Let's make those y's cancel out. To make y's cancel out, they need to have opposite coefficients. So to do that, I'm going to take the top equation. I'm going to decide to multiply everything up top by 2. All right. Now, because I want these to be opposites, again, when we want to combine these equations, if we can set it up to combine with addition, we should. Just makes our lives a lot easier. So I'm going to look at this and go, what do I need to multiply -4 by to get +12? And the answer there is going to be -3. Okay, so everything in the top equation is getting multiplied by a +2. Everything in the bottom is getting multiplied by a -3. And we're going to write the results below. 2 times 4x is going to get us 8x. 2 times -6y is going to get us -12y. And 2 times 26 is going to get us 52. Down below, -3x, or -3 times 5x is -15x. -3 times -4y, that gets us our +12y we wanted. And -3 times +8 is going to get us -24. Everything is set up now so that when we add these two equations together, the y's are going to go ahead and cancel out. So let's combine everything else. 8x plus -15x is going to get us -7x. And 52 plus -24 is going to get us 28. So we get -7x equals 28. We just finish off by dividing both sides by that -7. And that's going to get us x is equal to -4. Just like before, we're going to take that value for x. We're going to plug that in for x in whichever equation we want to. I will pick the bottom one. So 5x minus 4y equals 8. And again, we're just going to take that value for x. We're going to plug it in for the x all the way up here. And that's going to look like 5 times -4 minus 4y equals 8. We simplify with our multiplication. That's going to get us -20 minus 4y equals 8. Now we're just going to add 20 to both sides. We end up with 28. And we're going to finish off with our division of -4 on both sides. That's going to end us with y equals -7. All right. So now we have our solution for these lines. They both cross at that point -4, -7 on the graph. Okay. So that's 4 practice problems with this process of elimination. In another video, we're going to cover the rest of this worksheet that deals with how you can tell whether solutions or systems are equivalent, and a little bit of an application problem. All right, I'll see you there.